Good day everyone, my name is Ravi Badoria. This presentation has been uploaded to YouTube. The video link has been provided in the submission slide. The title of my project is Malicious URL Detection Using Feature-Driven Machine Learning. With the rapid growth of internet uses, cyber threats have increased significantly. One of the most common ways attacker spread this threat is through malicious URLs. These URLs are often used in phishing attacks, malware distribution, credential theft, and online fraud. They can affect individuals, organizations, and critical digital systems. Traditionally, blacklist-based systems were used to detect malicious URLs. These systems work by matching URLs against known malicious lists. However, attackers now constantly generate new or obfuscated URLs, which allows them to bypass static blacklist. Because of this, there is a strong need for intelligent detection system. Machine learning helps address this problem by learning patterns directly from data and identifying malicious URLs based on their internal characteristics rather than fixed rules. Malicious URL detection has been widely studied in cybersecurity due to the rise of web-based attacks. Early solutions mainly relied on blacklist-based and rule-based techniques, which are effective only for previously known threats. Due to their limitations, researchers moved towards machine learning based approaches. These approaches are commonly grouped into content based, host based, lexical feature based methods. Content based methods analyze web page content and scripts but are computationally expensive. Host based methods rely on information such as domain reputation or registration details and often depend on third-party services. Lexical and structure features-based methods analyze URLs directly, making them faster and more suitable for real-time detections. This approach is strongly supported by existing research. Based on the literature, this project uses a feature-driven supervised machine learning approach with labeled benign and malicious URLs. A feature-based approach was selected because it does not require web page content or external reputation services, making it efficient and scalable. Three models were chosen for evolution. Logistic regression was used as a baseline because it is simple and easy to interpret. Support vector machines were selected because they perform well in high dimensional feature spaces. Random forest was chosen as an ensemble model that can capture complex non-linear relationship between URL features. These models allow comparison in terms of performance, robustness, and interpretability. This project follows a standard machine learning pipeline, including data collection, pre-processing, feature extraction, model training, and evolution. The dataset was obtained from a public Kaggle repository and analyzed using Google Colab. Initial data analysis was carried out to understand class distribution and data quality. During pre-processing, URLs were converted to lowercase, duplicate entries were removed, and invalid URLs were discarded. Labels were converted into binary classes. Lexical and structural features such as URL length, number of dots, slashes, digits, special characters, and IP address presence were extracted. The dataset was split using stratified sampling, and models were trained using cross validation to ensure fair and reliable result. This slide shows the class distribution in the dataset. Benign URLs makes up the majority, while malicious URLs represent a smaller portion. This reflects real world traffic, but it is also means accuracy alone is not enough. A model may appear accurate while failing to detect malicious URLs. So, additionally, metrics are required. Benign URLs are generally shorter and follows standard structure. Malicious URLs tend to be longer and more complex, often including unnecessary parameters or obfuscated string. This clear difference shows why URL length is useful feature for detection. Benign URLs usually contain fewer dots, matching normal domain structures. Malicious URL often use multiple subdomains to imitate legitimate website or hide their destinations, which increase dot count and help distinguish them. Most benign URLs use domain names rather than IP addresses. In contrast, many malicious URLs embed IP address to bypass domain-based detection system. This makes IP address presence a strong indicator of malicious behavior. Logistic regression achieved an accuracy of 77% but performed poorly in detecting malicious URLs, as shown by low recall for the malicious class. Random forest performed significantly better, achieving 94% accuracy with strong precision, recall, and F1 scores. This shows that ensemble models handle class imbalance and complex patterns more effectively. The ROC curve for random forest model shows strong performance with an AUC value of 0.979. This indicates a high true positive rate and a low false positive rate, which is important for real world security system. Feature importance result so that URL length, number of dots, slashed, and special character contribute most to classification decision. Features like IP address versions and the @ symbol have lower importance. Suggestions overall URL structure is more important than individual indicators. In conclusion, this project shows that features driven machine learning can effectively detect malicious URL using only lexical and structural features. Among the tested models, Random Forest achieved the best performance. However, the study is limited by the use of static dataset and handcrafted features. Future work could include live dataset, contextual features such as domain age, and deep learning models. Overall, this approach provides a lightweight and scalable solution for malicious URL detection. Thank you for listening.